Hi and welcome back. So in this video we're going to do problem number 27 out of the first recitation from signals. So the question is, which of the following curves is most likely the plot of cosine of 2t? So now from this they're asking us to choose which graph. And so the best thing to do is we can see, first off, the best thing to do is look at the graphs and see how do these graphs vary. All the graphs have got the same amplitude, so it doesn't make sense to figure out, okay, we have an amplitude of 1 here, so our cosine should go from positive 1 to negative 1, but they all do that, so we can't eliminate anything that way. We also could look at this in terms of the phase shift. We could look at what the phase shift of our cosines are, but if we look at this again, all of these cosines at time is equal to 0, they all equal 1. They all equal 1 at time is equal to 0. So it doesn't make any sense to say, like, okay, well, which one of these cosines doesn't have a phase shift? None of these cosines have a phase shift. So now, if we can't use k and we can't use phi to figure this out, remembering that a general cosine is k cosine omega t plus phi, the last thing that we can use to figure this out is omega. Once we know k, omega, and phi, k, omega, and phi define what the cosine is. That is the cosine. So we know we can't use k, we know we can't use phi, we know that for all of these cosines, k, that all the k's are equal, we know that all of the phi's are equal for all of these cosines, that all of our k's are equal to 1, all of our phi's are equal to 0 because there's no phase shift. So the way they vary is in terms of omega. So one way we can figure out, and probably the best way I can think of to figure out exactly how these vary, is remember that omega is equal to 2 pi f, and that f is equal to 1 over the period. So the period that it takes for one cycle to repeat. So if I take this period and substitute it in here for f, I get that omega is equal to 2 pi times 1 over the period. And now what I'm going to do is I'm going to say I'm looking for a cosine where my omega is equal to 2, right? That's the omega I want. So I'm just going to go ahead and substitute in 2 for omega. So I'm going to say 2, that's what I'm substituting in for omega, is equal to 2 pi times 1 over t. Now I'm going to multiply both sides by t, so I get t times 2 is equal to 2 pi. And now I'm just going to divide both sides by 2, so I get t is equal to pi. So now I know that as soon as I find one of these cosines that has a period that repeats every pi, put in the units, every pi seconds. If I find a cosine that repeats every pi seconds, I'll find the right cosine. So let's start with the first one. Well, we can see that I start at 0, and I don't repeat until I get out here. On my axes, it looks like, I don't know, that's maybe like 6.4 is equal, here, I know it doesn't look great when I erase on this white paper. So it looks like here my t is equal to, I don't know, maybe 6.3 seconds, something like that. So that's my first graph, my graph A. Now let's move down to graph B. So I start here at 0, and I repeat here, and oh, look at that. I repeat at like t is equal to, I don't know, that looks pretty close to pi, I'd say, 3.14 seconds. And then let's go down here for the very last graph. I can see I start at 0, and I repeat maybe at like t is equal to 2.1 seconds. So I can see that the most likely graph for cosine of 2t, because I'm looking for a period of about pi, and remember that pi is approximately equal to 3.14, the most likely candidate is graph B. That one is most likely the graph of cosine of 2t. So the answer is B. Hopefully you found that useful, and I guess I'll see you in a future video. Thanks for watching.